All right, good morning. Welcome back to Pre-Calculus. We are going to be looking at problem number two here. So we have two guy wires that this is a Dutch term. And pretty much what we're doing is we're trying to stabilize this pole. Okay, and that's what we're trying to do with this. And then we want to know how long the flagpole is. And we're given two pieces of information. We're given that we have a 39-degree value here, with this wire being 11.2 meters. We have a 47 degree thing. We are not given the length of this wire, and then we have to figure out the length of this whole pole sitting right here. So let me draw a little bit of a picture. Okay, so we have our picture of what's going on here. Let's see, we have, that was 11.2. So we have 11.2 here. We have a little bit of a value down here of 39 degrees. Okay, and then up here we have our 47 degrees. All right. Okay, I'm going to go ahead and make an assumption that we're going to go to one decimal place because the problem is given to us with one decimal place. So we'll go ahead and, oh, nearest tenth of a meter. So it's one decimal place anyway. And we have to figure out what this whole length is here. All right. So the first thing we have to do is we have to figure out what's going on with this. Now, one of the first observations I'm going to make is that this middle triangle here is not a right triangle, meaning that we can't directly go into what's happening here. We have to go with the little triangle and then work our way up to what's going on everywhere else. So I need something that's going to relate hypotenuse, an adjacent side, and an angle, because those are the three pieces of information I have. And hypotenuse, adjacent, and angle, that screams cosine. So we're going to say that the cosine of 39 degrees is equal to the adjacent over my hypotenuse, right? Now my hypotenuse is 11.2. So we're going to say this is cosine of 39 degrees is equal to my adjacent side divided by 11.2. We're solving for adjacent, so that's a semicolon. So we're going to say that 11.2 times cosine of 39 degrees is equal to my adjacent side. And we're going to go ahead and evaluate what that is. I'm going to go ahead and take out my handy dandy calculator here. All right, which we have right here. And we're just going to say, make sure that you're in degree mode. So mode is not in degrees right now. That's not going to be helpful. Let's change to that. Quit. And then we're going to be able to say 11.2 times, and we want cosine of 39 degrees. And in here, we're going to see this is going to be 8.7 meters. Okay, so as I go through and start filling in parts of my triangle, this is 8.7 meters. Now, I have this little triangle kind of sorted out. We could figure out this side right here. We don't have to because they want the whole thing. So now we have a 47 degrees. We have an opposite side that we'd like and an adjacent side that we have. Beg your pardon. So we're going to say that the tangent, because we need opposite, adjacent, and angle. So that's tangent. So tangent of 47 degrees is equal to my opposite side divided by my adjacent side. We're solving for the opposite side. So we're going to say that opposite is equal to the adjacent times the tangent of 47 degrees. And at that point, we could say opposite, right, equals 8.7 times tangent of 47 degrees. And again, we have a nice little calculator sitting here, so we're going to use that, and we'll say, okay, we have 8.7 times the tangent of 47 degrees. We're still in degree mode, so we can go ahead and do that. Yep, we're all set. And this turned into 9.329. Rounding to the nearest tenth of a meter, we're going to say this is equal to 9.3 meters. And that is our answer for this problem. Okay, so this is a pretty standard kind of a problem. You should be able to do something like this. So good luck with it. But yes, always take an inventory of what sides you have, what angle do you have, and relate the trigonometric ratio to the appropriate trigonometric ratio to what you have. Okay, thank you very much for watching, and I will see you in the next video.